Welcome to this episode of the Civil Engineering Podcast, the first podcast dedicated to helping civil engineering professionals succeed in work and life. I'm your host, James Taylor, and in this episode, I'll be talking with Dr. Paul Chinowsky, Director of Analytics and Resiliency at Stanley Consultants, about his transition from academia to the industry, the skills engineers need for climate change challenges, and his views on the future of civil engineering in this ever-evolving field.
Before we go on here, I'd like to recognize our sponsor for today's episode, Stanley Consultants.
For over a century, Stanley Consultants has been at the forefront of engineering innovation, relentlessly committed to improving lives and building a resilient future. We collaborate with government agencies, utility providers, and private industries to solve some of the most complex challenges in energy, infrastructure, and more. We put people first, leveraging cutting-edge technology and multidisciplinary expertise to deliver differently and exceed expectations. Be a part of our journey to create a connected, sustainable, and enriched world for all. Get in touch with our Stanley Consultants team today.
It's now time for our civil engineering conversation of the week with Dr. Paul Chinowsky. Paul, welcome to the Civil Engineering Podcast.
Thanks for having me. I'm happy to be here.
Paul, I read a lot about you, was learning and studying as I was getting ready, but can you share for us your career journey, the pivotal moments that led you from academia back to the industry, particularly in the field of climate change?
Sure. I can say that my journey is not a straight line. I'd love to be able to say that climate change was something that I had intention my whole career to do. And really it was a little bit of, like most people, kind of a realization. I started out as an architect and moved into engineering really from the computing side, technology side. It was PCs were really just coming out when I started, was in undergrad. I was like, this is going to change everything. So I went to grad school really focusing on computer science and civil engineering, and worked for a consulting firm for 3 years and had a really exciting time learning about how industries as diverse as aerospace and automotive, we were all doing design, and had the opportunity to go back and teach, which I really loved doing, and did that for almost 20 years. And about halfway through, I had a colleague that was doing some work in Alaska where they were really looking at the start of climate change impacts on indigenous communities. And he called me up one day and he said, we're trying to figure out a model for how people would adapt. He said, I don't think this would be too hard. You do work like this. Why don't you take winter break and spend a couple of weeks on the question? Well, 20 years later, I'm still perfecting those answers. And it was one of those things where once I understood really what the issues were, and we got connected just because we had done that with the World Bank and the UN and started to look internationally. And that really changed my career. This is something that we had to figure out as engineers, that how are we going to adapt? And that started that journey. And about 3 years ago, I really had to make the decision, was I going to stay in academia and be a researcher on this, or was I going to jump full speed into my consulting work? And there was just so much demand at that time. I said, I need to make a difference. This is what I need to do.
That climate change, resiliency, and all those topics, I mean, it's really big right now in the civil engineering industry. And it seems like, the research was the place where it was at before. And you've kind of, like you said,
Exactly.
made that transition into the consulting world because I'm guessing you're seeing that more and more people are needing that consulting versus just the research.
Absolutely. It's both in the public and the private sector. The private sector, they're figuring out supply chains are so fragile with climate change. We always thought that it was really good to have distributed supply chains and go for where was the best value. And now we're finding out that dependence is really problematic. And public sector, if you think about it, everything that we've designed and built over the last 30 years, 40 years, was designed for an environment that's not going to exist 5, 10, 15 years from now. And that is literally trillions of dollars of work that needs to be done.
So you talked a little bit about the Alaska thing and what initially inspired you to focus on climate change? Because 20 years ago it was talked a little bit, but probably not a lot. And how did you first realize that this was that career path that you wanted to continue to pursue?
What really impacted me first in the Alaska work was looking directly at the erosion that was occurring on the coast and how entire villages were being lost. And the question came really from the group I was working with. Well, how much coastal infrastructure do we have that is really vulnerable? And that was such an interesting question to me about how much of our infrastructure is vulnerable to climate change, and led me to, well, how much of an issue is this? Where do we start? I think that was the biggest thing for me as a career. Where do you start? Do you start on learning science? Is it coastal engineering? Is it landslides? What is it? And I think that was what was really excited me, was climate change brought everything I knew from all my different areas of background together into one new area that was so applicable, so new, that we were going to make a difference. And that, to me, that's what everything about this profession is about. How do we solve new problems?
So reflecting on your time in academia, now in industry, what are some key differences you've noticed in how each sector approaches climate change?
So in academia, a lot of it is what I would call broad discovery. How do we know where the issues are? How do we theoretically address water supply? How do we the broad questions? So it was really the foundational work. The getting back into the industry, the consulting work, it's answers, it's application. When someone comes to you and says, we need to know right now what are our most vulnerable areas and our priorities, this is not theoretical. This is not abstract. They want to know, this is
happening.
This is happening. How am I going to prevent a flood on Front Street? And is that where we should put our money?
Yep.
The other piece of it is really about vulnerable populations. In academia, we spend a lot of time looking at how do you identify what are these vulnerable populations. I'm focusing on how much of the population needs air conditioning and where is that energy going to come from and who's most at risk. So it's really focused versus broad range. They're both very valuable, and it just depends on where you really personally have that interest. And for me, I love the application. I love the solving the problem and getting in there, getting my hands dirty type thing.
So how is your background in engineering and even architecture, right? Because you started out in architecture. How have that specifically prepared you for the unique challenges of climate change analysis?
I think where my background really served me well was I brought together a lot of different disciplines. So from the architecture side, you really understand building systems. You also understand the people side of things, right? The clients of what do they need. The engineering really we have to solve a problem. We have to break this problem down and come up with an answer. And then my background in computing really was, well, how do we model this? How do we capture this? So I think I was in a unique position where I brought multiple perspectives together to say, how does the science impact us? How does it impact the built environment? And that was unique at the time that I got started 20 years ago. Now we see a lot more people involved in it. But I think that was the piece that really brought all the diverse parts of my background together. And that has served me well, and I think is what has enabled me to really work in all different types of scenarios and with groups of people around the world.
In your view, what are the essential skills that the next generation of engineers need to effectively address climate change issues?
So I think we are in a generational change, and I think we use that term maybe too much. But I think for people coming into the industry today, it's not just the deep dive into engineering skills themselves. I think you've got to learn a little bit more about the science, the climate science. You don't have to be a climate scientist, but you sure need to understand data. So I think data analysis and the environmental science are two things that are very important that we probably didn't spend as much time before. And I think the third skill is working with diverse groups, because you have to be able to understand and communicate with groups who need to adapt, who need to make change. And your role is not anymore just the person sitting in the background. You're actually there on the front line helping to make change. So it's communication, it's data analysis, and environmental science. I think those are three really new skills that are going to change education and going to keep challenging us to rethink what the next generation of engineers are all about.
Talk a little bit more about the environmental science aspect of it. I think, as civil engineers, we look at our counterparts in environmental and sometimes say, they're, really focused on that aspect. And my perspective as a civil engineer has been that as a civil engineer, we are able to make a large impact because of what we do on the environment. So can you talk a little bit more about just the environmental science aspect that you were talking about?
Yeah, so a couple of things are really common questions that we get a lot that we have to look at. One is contamination from water runoff from roads. We used to always think about this as, well, this is a drainage problem. It's we hire the environmental engineers who come in and do the environmental impact report and give us some ideas. Now this is fundamental design of what happens when the intensity of rainfall is 3 times what it used to be. What does that mean? And I think it's that, what does this mean in terms of impacting the environment, that becomes very important. The other piece of it is really understanding when the climate scientists and models say it's going to be hotter or it's going to be wetter, to be able to answer the question, well, why? Why is that? Because when you're working with a client, you don't always have the ability to say, well, hold on, let me get in touch with my environmental person and they'll give you an answer in a couple of days, right? They want to know, why is this happening? And you need to be credible in your response. You don't have to be an expert, but you need to move the conversation forward.
You need to have enough of that basis to be able to say, here's what's going on. And that's where I think you talk about diversifying the people around you. You might not be that expert, but having those people around you you can learn from helps with that a lot.
You need to be the central communication hub. That's what I tell my team. You have to kind of be the person that translates abstract science into impacts, from road design to what does this mean for a budget. So you find yourself in the middle a lot of the time, and that you have to kind of embrace that. Go, okay, I'm not going to be afraid of it. It's the challenge that I'm going to embrace and that I enjoy.
I love that. Yeah, that's great. You hear a lot of people talking about being the quarterback, but that central hub I like even more, because it really is that everything's going out in all different directions.
Exactly.
That's a really, really great analogy to make. Climate change is rapidly evolving field, right? I'm sure it's much different now than it was 20 years ago. Than when you first started looking at this. How do you stay up to date and adapt your skills accordingly as things evolve, as new science becomes available? Like, how do you keep up on that stuff?
You have to commit time every day to read what's going on. I think I read more now than I did when I was in graduate school, just because every day there's new things, whether it's policies coming out, whether it's people advocating things, it's new science. So every day, the start of my day is always, I spend about 45 minutes every morning going through what are new things that are going on, what's come out in the last week. And that's critical. You can't fall behind, because I've learned this the hard way of, if you fall behind, you're bound to talk to a client that says, well, I just read this. What do you think? And there's nothing more disarming than being in a situation, and especially in a room full of professionals, where you have to say, I haven't seen that yet, right? You don't want to be that person, because your credibility just goes out the window. So you have to read. You have to read all sides of things. Do not get into the mode of, I only have 3 people that I pay attention to, or 3 sources. You've got to know all the different sides of the arguments. What are the policies? And that's key. You've just got to keep up every day.
Yeah, I was going to say the last point is very important, right? Because I think, and I'm sure you've experienced it, climate change and those discussions can be very controversial.
Yes.
In a lot of areas, and you need to understand both sides of it, or else you can't have your arguments prepared. You need to have multiple things, and then you need to figure out what that. So is that something where you go through and you kind of look at all the different things and say, okay, here's what my background and my expertise I've seen, and this is where I'm going with that? Or like, how do you approach that aspect of it?
Exactly. And especially when I'm talking to clients, I say, the first thing we got to do is, let's strip politics out of this. Let's talk about what needs to be done. What do we know as facts, or at least what do we know as really good science and engineering? And talk to people that way and be very honest. Here's what we know. Here's what we think we know. And here's what we don't have a great idea on. And people respect that. I am just as happy to talk about what we really are confident about as, well, this is where professional judgment has to come in. And ultimately, this is risk management. And people like to think of things in that way, right? When you put it in very practical terms, don't talk about, I think the mistake we've made as an engineering community is we like to talk about this 2 degrees warming. We'd like to talk about these big global things. Yeah. You immediately lose 90% of your audience, right? That's not the way to do it. One of the things that we always do is when we talk about impact to roads, I talk about what is the cost going to be per mile, per year, if you adapt or if you just wait and see. Everyone can relate to that. This mile of road is going to be a difference of $100. Okay, we got that. We can make decisions about that. If numbers get too big and abstract, you lose people. So put things in the context of what they can understand and be very honest with them about what you know and what we don't know.
I love that. That's a great point, and kind of brings the parties together.
Yes.
Which is exactly what needs to happen. Where do you see the intersection of civil engineering and climate change heading in the next 10 years, the next decade?
I think we are headed for probably one of the biggest uncertainties or investments, biggest policy places that we've been really since 1950s, 1960s. If you think about, go all the way back even into the 70s, let's go back, clean water, clean air. There were a lot of assumptions that we made as a country about building infrastructure, that we were going to invest in this, but there was going to be continuing money to keep this up, right? That was a big assumption. Mm-hmm. That hasn't happened. So now we're at the point of, we're going to rebuild. We're going to redo our national infrastructure, everything from local neighborhood roads to water systems, et cetera.
Yeah.
Well, what are we going to build to? What is that standard? And this is as much an ethical question as it is a pragmatic question. So engineers are trained. We know what building codes say. We know guidelines tell us whether it's steel or concrete, whatever it is, we know how to use guidelines. So now we have the question, do we rely on what we've always relied on, past 30 years of historic data, or are we going to design the next generation of infrastructure to what we think is going to be the environment that's going to operate in? I think this is the biggest ethical dilemma that we have as engineers that we've seen in decades. And it's where things are going to come together. At some point, we've got to make a decision. What is the infrastructure going to be like? And should we be building the same infrastructure? I think we're already seeing that with, we're seeing investments in high-speed rail. Is that where we should go? We're not going to build the interstate highway system again. So
right.
What are we going to do?
That's done.
That's
not
done.
touching that one again.
Right. We're not going to do that. So what is our vulnerability and how do we prioritize? And I think that's where over the next decade, that's the conversation that's going to dominate, is we can't just keep doing what we've been doing, but what do we do next?
I love that. This has been really enlightening, hearing about this and your perspective on climate change. Lastly, what's your final piece of advice for listeners who are aspiring to build a career in this ever evolving and challenging field of climate change?
I think two things really. One is broaden your knowledge base, right? The more articulate you can be, and it doesn't mean going to take classes. There is so much on the internet that you can go to in authoritative places. Look at the National Climate Assessment. It's probably what I always tell people. It's the first place to look. You can learn about science, engineering. You can learn what's going on. Look at the IPCC and the international panel on climate change. Educate, right? That's the first thing. The second thing is really a change in how you talk to people. Don't assume you are the smartest person in the room on everything, right? That is always what we've been told, is you get up and you present, you are the expert, control that room. Now it's a little bit more of respect your audience. Everyone in that room's bringing a different perspective, a different important perspective to solve a problem. Learn to communicate. I go back to that central hub. Learn to bring people together. That if you can do those two things, learn to communicate as a hub and broaden the base, that's your starting point to really enter into this very quickly evolving field.
And the funny part about both of those things is they have nothing to do with engineering.
No,
it has everything to do with people. And I think that's kind of the whole aspect that you've been talking about is with the ethical dilemma that climate change is. You have to understand people and you have to communicate with people.
Exactly. People and communication. That is, you can always quickly pick up the technical, right? That we know how to do. And I do that all the time. And I know when I'm getting out of my depth and who to ask. But you've got to be good about that communication and always be open to, I got to learn more. What am I learning today? That's a key part.
I love it. All right. Well, now it's time for our CE Hot Seat segment of the week with Paul Chinowsky. Do you understand how this goes?
I understand. Let's do it.
Before we go on here, I'd like to recognize our sponsor for this episode, PPI, a leader in engineering exam prep for the FE and PE exams. PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
Welcome to the CE Hot Seat. Are you ready to go?
I'm ready to go.
All right, Paul, do you have any specific rituals that you practice every day? For example, do you have a specific morning ritual, lunchtime ritual, things that you do consistently on a daily basis that contribute to your success as a professional?
30 minutes in the morning, guarding my time to read the paper. I shouldn't say paper anymore. I read the news, right? What's going on? Every day at lunchtime, I go for a walk, clear my head, and think about what are new things that I want to do. It is routine I guard religiously. It's my time.
What is one book that you recommend to engineers regularly, or just one book that you have found to be extremely helpful in your professional and or personal development?
So this may sound a little strange, it's a little on the HR side, but I am absolutely convinced there's a book called Please Understand Me. It's by the people who developed Myers-Briggs personality. And I'd say that because it's really important to know how each person on your team thinks and works so you can put teams together effectively. So I always say, start with your people, understand them, build from there.
Thinking back on your past managers, picture your favorite manager or managers. What made them your favorite?
They were visionary and they trusted my judgment. They said, here's where we're going to go. This is the vision we have. Now let's go do it. I trust you to make good decisions where you are. Let's do this together.
We've got one final question, which is the critical civil engineering career elevator advice question. If you got into an elevator with a civil engineering student, which might have happened in your past, if you got into an elevator with a civil engineering student and had about 30 to 40 seconds with them, what career advice would you offer them?
Always be open to learning more. Never assume you know everything, and make sure you're passionate about it. Passion doesn't die. Technical experience wears out. Learn, learn, learn.
I absolutely love it. Paul, thank you so much for joining me today. Can you tell us a little bit more of where our listeners can connect with you?
So you can go to our site on resilient-analytics.com, or feel free to send me an email, Chinowsky at resilient-analytics.com. I am always happy to connect with people, give them advice, point them to directions to learn things. I am absolutely an advocate for know more about this. I'm here to help.
Awesome. Well, thank you so much for your time, Paul, and we'll be connecting with you for sure in the future.
Thank you.
Please remember, you can find the show notes for this episode at civilengineeringpodcast.com. There you will find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during the episode. Until next time, I wish you all the best in your civil engineering endeavors.